Now we talk about the electrical properties. Then high electrical conductivities. It's about graphene's electron mobility is about, you can think about 2.5 lakh centimeter square per volt second. Okay, so much higher than that of the silicon. Okay, which is 1400 centimeter square per volt second. So okay, these all are for the electron purpose. We just may leave leave that. So thermal properties we must have to see in here. So highest thermal conductivities, which is about around 5000 watt per meter Kelvin. Okay, Kelvin is for the temperature, meter for the length, and watt is for the power or work. Okay, so higher than the diamond, which is 2200 watt meter per meter Kelvin. Okay, so you can say it is a 5000 here only, less than. I mean, you can say you can see the graphene has a more than 2 times of the diamond conductivity. Thermal conductivity we are talking about here. Dissipates the heat efficiently, the use in the heat sink and electronic cooling, because they are having the very high electrical conductivity. Sorry, thermal conductivity. Now we talk about the optical properties. Okay, so high transparent absorbs only the 2.3% of the visible light and making it nearly invisible. Okay, but rest all are just cross reads. Can be tuned for the optoelectrics used in the transparent conductivity films and the flexible display, that we are not here too much give to attention, because these all are not mechanical properties. We must have to think about the mechanical properties, that it was this, and thermal properties. Chemical properties sometimes we can see, otherwise we can leave it, no issue. So high surface area. Okay, surface area means what? They are having the surface which are exposed to the environment. Okay, which is having 2630 meter square per gram, useful for the energy storage and sensors. Chemical stability, the resistance to the oxidation and corrosion, making it durable. If we talk about the functionalizations, they can be modified with the chemical groups for the various applications.